Oh, did I accidentally end the poll, like for everyone, or?
We're doing that again. Take the poll again.
Yeah.
Sorry.
Hi, everybody. Thanks so much for joining us. We'll get started as we get everybody in the door, this virtual door here. And in the meantime, you can take our poll. And this is going to be a very interactive session. So you may want in your name under participant to tell us who you are. So if you go to participants, which is at the bottom of your screen, and click on your name on the right-hand side, you should be able to do a rename. So if you want to either put your neighborhood or put your organization or some other information about yourself, that would be great, what university you're at. That way we all can get to know each other, and when we actually do our interactive session, we'll know who we are. Anybody need help with that? Okay, good. We're seeing some of you do that. And Bina folks, make sure you put Bina next to your name. And then also you might want to keep the chat open because we're going to put a lot of stuff in the chat. I guess Cheryl, you are a chat person today for this one. And this is going to be our most interactive session, so we're going to actually even do breakouts towards the end too. All right, I'm going to go ahead and share my screen. Let me make sure I can actually do that. Okay. What are you all seeing? Are you seeing my Teams?
Yeah, that's what we see.
That is actually what I want.
Screened.
Sorry, I should have had this open before. All right. Welcome, everybody. I'm going to try and actually make this go to slideshow from the beginning. Okay. Everybody can see that? Okay, so thanks so much for joining us for this penultimate session for Baltimore Data Week. Hopefully everybody's been having a good week so far. And now is when we think about how do we really use all these skills for data science to use for social good in Baltimore. So let me give you a quick overview of what we've been doing at the Baltimore Neighborhood Indicators Alliance and why we're so excited to be a part of this multi-university project, which you'll learn more about. So this is our 20th anniversary. Going back to 2000, we are the 6th partner of now what's a 30-city partnership around the nation called the Baltimore Neighborhood Indicators Partnership. And so what this partnership has been really is a learning network. really trying to learn how and we can continuously provide data to communities. And so I call this very much a living project. The Baltimore Neighborhood Indicators Alliance is very much a living project. And so we're constantly learning, not only from these other cities, but learning from each other and learning from best practices on how to do this work. It's a little bit like trying to steer the airplane while you're flying. And that's what the last 20 years have been like. We've been trying to do this work as we're learning to do it. We literally were the first open data set for the city of Baltimore when we released basically machine readable data, that people could actually use for their own analysis back in 2002 when we first started releasing information. And the ability to use the data yourself, not just read it in a report, was a relatively new phenomenon, right, in the early 2000s. This is the first vital signs, and this used to be our old logo, the original logo for Aryya when it was created. And going back to our mission for open data, right, democratizing data, putting data in the hands of communities, it's kind of started just with open data, making sure that there was machine readable data for people to use, but that has slowly morphed into open source. If we're going to have open data, we should be involved in open source as well, because you have to look at the code to be able to see what we're doing to make sure that our analysis is, community driven as well, not just the data. And if we're going to go to open source, we have to get to open knowledge and actually share everything that we know in this, plane that we're trying to drive at the same time as trying to figure out how to work it. Which of course leads us to open education. And you're going to see a lot of what the project that you're going to hear about is really all about trying to help all of us that are teachers learn from each other and actually create an open education way of standardizing data science in the region for social good. This all started from a Baltimore Data Day session back in 2018, where we met Dr. Gangopadhyay from the University of Maryland, Baltimore County, who you'll hear from in a second. And so really thinking about how can we take some of the work that we had just started working with the University of Maryland at the time, learning about what do smart cities mean for our neighborhoods and how can we use data to create a smarter city and a smarter citizenry, I should say, not just the city itself. So these are kind of the components of smart cities. What is a smart economy, entrepreneurship, innovation, what's smart government, e-governance, evidence-informed decision-making, what's smart mobility, interoperability, multimodalism, shared services, what's smart environments around renewable energy, sustainability, what's smart living, improved quality of life, right? In the end, this is where Aryya, I think, fits pretty squarely of why we would be interested in this, because we are interested in improving quality of life in all of our neighborhoods, increasing safety, reducing risk, and I would obviously add, reducing inequality, part of kind of why we do our work. And of course, creating smart people, which should actually probably be at the top, informed citizenry, creativity, inclusivity, and empowerment. And so instead of thinking of all of us as being the subjects of the data, right? If we look at any data, they're about people. We really have to turn all of us into data citizens. But it's not enough to make us that use data into data citizens, or the people for whom the data is about to become data citizens. We actually really need to make our data scientists be a part of data citizens as well. And so we have a new crop of young people that have been looking at data and trying to get into data science techniques, and you'll hear from them. And that's how we got involved in this NSF project that you're going to hear much more about. But I want to talk a little bit like a manager, driving the plane while we're trying to figure out how to use it. When Aryya first started, we pretty typically had planners. I'm actually an urban planner. We had public policy folks, people that are involved in politics and community organizing were involved in the Aryya project, GIS analysts. We've been using GIS analysts, I think, from the beginning. You can correct me if I'm wrong, Cheryl, but Cheryl's been here. Cheryl is our longest serving PINA staff person. I think you said 13 years, and she's our GIS manager now. And these are the kind of skills that we've had in the project the whole time, but slowly we realized that we had so much data. We needed a database manager and thinking about DBAs being a part of our team. But we needed to do more than just, management of the data. We needed computer science background. We needed information architecture and, full stack developers. So Carlos Carpati was brought on board about 3 years ago when we realized that that's the kind of skill that we actually need. That's not to say we don't need urban planners. Hopefully you still need my skills as an urban planner. But we needed all this other stuff. And then beyond, the management of data, we actually need to get involved in library science. It's about querying the data at the right moment, at the right time. And so we've actually been working much more closely with our own library here at UB, but also with the Pratt Library to think about how do we get information out properly in a queryable format. So these are literally all the skills that we need here at a project like the Baltimore Neighborhood Indicators Alliance, believe it or not. And how do we actually bring on board, young people and new people into this project? And so here at the University of Baltimore, we are pulling students. We wanted to pull students with faculty in these two areas, information science and applied information technology. This is relatively new for us. We've always gone to GIS departments because that's where our kind of origins were. And so we're really excited to be working with our faculty in these two. And then students coming from those areas, but then also making sure that we as staff can impart in a more, in a less ad hoc way, the skills that we've been learning for the last 20 years. How to use GitHub, how to use GIS for folks that don't know GIS, how to use some statistical software packages that are free and available here at UB. And there's much more about this project on that website that you can take a look at. And today we're really excited to kind of work with our inaugural data science fellows, Ruth, Priya, Brian, Michael, and Naomi, and you're going to hear from them about what they've learned over the last couple of weeks. I think it's only been 6 weeks that they've been with us, but you're going to hear much more about, how they think about data science techniques that can be used for social good. That's a very brief overview. I'm going to turn it over to Aryya Gangopadhyay from UMBC to talk more about the overall project.
Okay, well, thank you so much. First thing I need to figure out is how to get the screen, share my screen.
Maybe all the way at the bottom. Green button at the bottom.
That's right, okay, great. Okay, hopefully you guys can see the screen.
Yep, and you probably want to do the display settings where you're just in.
That's right, okay.
Yep, perfect.
Okay, great. So I have about 5 to 7 minutes, so I'm going to be brief. So this project has been funded by the National Science Foundation, which is the primary federal funding agency for STEM research and education. My name is Aryya Gangopadhyay. I'm a professor of information systems at the University of Maryland, Baltimore County. So this is the title of the project that was funded. We have 4 universities. UMBC is what is known as the coordinating and implementing organization. We have Towson University of Baltimore and Bowie State as our partners. But in addition to that, we also have, and we are still building on this, several outside partners, for example, city agencies like the Annie Casey Foundation, but also there could be other state agencies like the State Highway Administration, and private partnerships are also encouraged to do that. The goal of this project is to really build the skill set and the knowledge that it takes to really build successful smart city projects. So we have divided this into several parts. There is the skill set that people need, and we're going to take it way beyond the core group of students that will be participating in this project and open it up to the entire world, in fact. So the project started about 6 months back. The initial funding came in October of 2019, but we really didn't get started until the spring of 2020. And so we are still, it's a 3-year project with a possible 1-year extension. So we are still at the initial stages of the project. We haven't really put this advisory board together yet, but we are looking to do that pretty soon. So what is a smart city? There are many smart city examples across the world and also in this country. So this is the one that I took because some of our projects are actually overlapping with this. So Buenos Aires is the largest city in Argentina, and also it's a capital city. And it its location, it's a port city off of the Atlantic Ocean. And there are 9 rivers that literally, there's a delta that pours a lot of water into the neighboring region, which is why it is very prone to flooding. And back in 2013, there was a flood that cost the life of about 100 people and many inconveniences with property damages and things like that. You can see a picture of that on the top right corner of the screen. And many of the reasons for this flooding, which sometimes is flash floods, which are very unpredictable and very quick and very dangerous, are because of the obstruction that are created by debris in different locations where the drainage can take place. So in 2013, they put together a project, a smart city project, and essentially they started, data collection using sensors, and then they kind of integrated that, made the citizens know about the flash flood situations, and also the drainage systems were controlled. And the next year, in 2014, was the year that they had the worst flood ever. And in fact, the number of lives that was lost was 0, and there was not much flooding as a result of this initiative that was taken. So that's just one example of many different types of things that can be done in cities to make the cities more efficient and functional. And just for a comparison, there are about 3 million people who live in Buenos Aires, but about 15 million people in the greater Buenos Aires region, and about 250,000 people are directly vulnerable to any flooding situation. It's very close to the sea surface. It's about 85 feet above the sea level, I think. So now, this is sort of a roadmap for smart cities. The first thing we have to do to apply data science is to collect the data. So that's really the first step. Now, in many cases, the raw data itself is not as valuable, particularly if you want to visualize. So there is data summarization, and a lot of times data is missing, and so therefore there are some data implications that are needed sometimes. Now, in this day and age, big data is something that is valued and also possible. So sometimes the raw data is actually fed into algorithms that are called machine learning or deep learning in more recent years, or big data analytics. And then there are other techniques like geospatial analysis and virtual reality that are part of data science, which we actually cover in this data science core project. And then there are some applications up top that are shown, but these are not an exhaustive list. There are many other applications that will be part of it. And this data science core is part of the HDR program, which stands for Harnessing the Data Revolution, which is one of the top 10 ideas that National Science Foundation has right now. So here's some statistics. Smart cities are actually a global problem. It is predicted that about 70% of the population will be living in the cities by another 30 years or so. Cities also produce a very large percentage of the energy, the greenhouse effects, greenhouse gases. They also are the largest consumer of energy. There are lots of problems, traffic congestion, and other issues, crime and things like that. But cities also produce about 85% of the GDP. So we cannot really live without it or work. Most people actually go and work in cities or nearby areas. Now here's an interesting statistic that 30% of the rush hour traffic is actually caused by people trying to find parking. And obviously smart parking would be an obvious solution to this problem. So this is an overall picture of our smart city projects. And I'm not keeping track of the time, so if I'm running out of time, please somebody let me know. The project itself consists of course modules that are designed to build skill sets and knowledge base, but it also involves actual experience in participating in projects that are related to smart cities and also research. So all three components are used. I have a project website link right here. I won't take the time to actually go there, but if you go there, you'll be able to get some more information about this smart city project that we have right now. So in conclusion, smart cities is a global problem. Almost every country is coping with it. Sometimes it's pollution, sometimes it's crime, sometimes it is space, sometimes it is energy, flash flood, and many other problems. Now, because it's a global problem, one can actually globalize the ideas, the technologies, and the solutions. So we can learn from each other. A system that was built in one city can be used in another, for example, instead of trying to reinvent the wheel and starting from scratch all the time. Now, there are also security concerns because with IoTs and other devices, the attack surface, the ways that people can launch attacks increases exponentially. And so therefore, that really is a concern that has to be taken into consideration. And new cybersecurity systems must be put in place. The biggest challenge is to have a trained workforce. There are very few programs that are dealing with smart city per se. There are many subcomponents like data science, machine learning, urban development, and things like that that are part of it. But we need something that really puts all of it together to create smart city environments. So I've got about 20 more slides, but I'm going to stop there for the sake of time.
That would be great. Thank you so much. So you can see the overview of kind of where this body of work is headed, but you got to start somewhere. And we're going to turn it over to, I just want to say, our three teams of data science students. It's been such a pleasure to have young people with us this summer, eager to learn and eager to kind of grind their teeth into all this stuff. So we appreciate you being with us this summer. And I'm going to turn it over to each of you. You have about 6 minutes. Brian, I think we have you going first, talking about scooters.
Yep, sounds good. Let's set that up. Awesome, cool. So just a little bit about me first. My name is Brian Kelly. I am a Data Science Corps intern at Pinya. I'm a University of Baltimore graduate, and I'm currently pursuing my upper division certificate in computer programming also at University of Baltimore, and I plan on graduating this fall. And I'm a huge film buff, and I'm very excited for my next opportunity to attend Toronto International Film Festival. I went last year, and after I went, I was just like, I want to go to this every year if possible. So getting into the project, we received a lot of data from the Baltimore City Department of Transportation about from private companies that provide dockless scooters for us to rent in Baltimore City, and those Jump, Lime, and Spin, and that's a picture of the scooters on the right-hand side. And the Baltimore City Department of Transportation launched the annual permit from August 1st, 2019 to July 31st, 2020. And to use them, it's like a fixed rate of $1 to unlock them, and then you get charged per minute afterwards, anywhere from 19 to 29 cents, depending on the time that you rent them and the area in which you're renting them. And there's also plans that you can purchase to cut the cost. And you see the prices before you actually start the rent. And we received the 5 months of data from August 2019 to December 2019. And for the first 2 months, you see about 250,000 individual trips across the scooters, all across the city. And there's less traffic in the colder months like October, November, and December, but we're still trying to figure out how to get that data out to see exactly how many trips were taken in those 3 months. But we took those coordinates and we were able to plot all of the routes that were actually taken by the scooters. And that's what you see on the right-hand side. It probably doesn't make sense yet, but it'll make more sense in a second. And these lines indicate the starting and ending points of a trip. And we took these routes and then we overlaid them on top of a map of Baltimore City, which you see on the left-hand side. And all of that mess of blue that you see in the middle, that is all the routes that is primarily focused, all the scooter usage that we notice is primarily focused in the white L, which is highlighted on the map on the right-hand side, which is like all of middle of Baltimore, bending out to Fells Point and Canton and Highlandtown, and there's very limited travel in the Black Butterfly, which is east and west Baltimore, and then even more so expanding out to getting closer to the county. And one of the problems that we wanted to address was that a large majority of the city does not have access to this very useful last mile form of transportation. So 31 out of 39 of the neighborhoods without frequent scooter use have over 50% of an African-American population, which I highlighted like on the map on the right-hand side. And it's a lot of neighborhoods. And only 6 out of the 16 neighborhoods of high scooter use have over 50% African-American population. And most of the neighborhoods have significantly less. And more so looking into the problem, or looking into what we found with this data, was that 70% of the population lives outside of the area with high frequency scooter usage. And that is like 430,000 people don't have access to this extremely useful form of transportation, and only 30% have exposure. That's the 30% live within those 16 neighborhoods. It's about close to 200,000 people have the option to utilize the scooters. And despite the uneven scooter distribution, the two areas have the same number of bus loadings per 1,000 residents. So 50% of Baltimore city residents can't utilize this last mile of transportation. So there's a huge disconnect between these public transportation and this very useful form of the last mile transportation. And so that's what we've done so far. And then moving forward, we want to be able to receive and analyze more data, and we want to fully colorize the map and the routes so they're more clear, and make it more interactive and provide more data. And we can also take the start points and the end points to predict the travel pattern, and we can make a statistical model analyzing the probability of where a scooter might end up depending on where it starts. And then we want to take this information and then publish a blog, a Binya blog. And then we were able to make all this using Colab's Python and the Altair library, and additional maps were made with Excel, and then maps were also used from Binya Vital Signs.
Awesome.
Cool. Am I over?
Nope, you're good.
Okay, cool.
Excellent job. So you can put questions to Brian in the chat for now, but you're gonna have time to kind of be in a room with him and ask even more questions when all of our fellows are done. So for now, chat questions, Brian, if you get any,
Sure.
And then we're gonna turn it over to Ruth, who looked at internet performance data. Ruth, are you good?
Yeah, I just need to share my screen. Okay, give me one moment. All right. So, sorry about that. All right, can everyone see it?
Yep, you're good.
All right, so hi everyone, my name is Ruth Robinson. I go to University of Baltimore currently, and I'm a business major. So over the summer with Binya, I've been exploring the question of, are all Baltimore City communities getting access to high-speed data? So to start, I want to give some background information. So I got my data from the Measurement Lab, or MLab, which provides a large collection of open source internet performance data, or speed tests, which include upload speeds, download speeds, round trip time, among others. And to put it in perspective, super fast internet speed, as advertised by some internet providers, is about 1,000 megabytes per second, whereas a slower internet speed, or a basic internet plan, is about 25 megabytes per second. If you were to do general web surfing, it would take about 1 megabyte per second, And on the other side of the spectrum, if you were to do frequent large file downloading, it would take at least 50 megabytes per second and up. So that puts things into perspective for the data set. So I got my data set by extracting like the average, the median, and some other parameters based on each Baltimore community. So I attached the Baltimore longitude and latitude information with the longitude and latitude for each data point. And I used that, I got that data from Google BigQuery, which codes in SQL. And once I got that data, I put it into Excel to make some visualizations. But a key thing to note here is that I only used data from March 3rd, 2020 to March 9th. And I felt like that week was important because it's the week that we transitioned from in-person learning and working to at home learning and working. So we would need a huge amount of substantial and fast even internet speeds at this point. So here are some of the visualizations. I kind of made a mix of a bar graph and a histogram. I wanted everyone to see the community names here, but we see that the data points are relatively uniform. So the average download speed is about 51.11 megabytes per second. And there are a couple of outliers relatively on the bottom here. So another way of viewing this data is geographically. So the red dots here represent those outliers that I mentioned before, but because the data is so uniform, it's kind of hard to see a pattern. But I do think that there is something here with these 12 points that are in red. So I wanted to take a closer look. And again, we see the uniformity, but the really important thing that I noticed here was the quartile 1 and the median, because we see that if we take the 25th point, if we split up the data into 100 parts and take the 25th data point, that data point is 3.6 megabytes per second. And the middle point of that data would be 15.4 megabytes per second on average. So that means that 50% at least of these Baltimore communities are getting 15 megabytes per second of speed. And it's only the top 5% of Baltimoreans in these communities that are getting what you consider fast internet speed. The lower 95% is getting basic or average internet speeds. So if I were to be brief in answering the question of are all Baltimore communities getting access to fast internet, I would say the answer is no, they're not. And that, like, this data has helped us to prove that point. But we do have to notice that the data is not exhaustive. It doesn't represent every single Baltimorean because it's based on voluntary participation. And it also does not account for those without internet. We can see from the BINYA website in 2018 that 21% of Baltimore households did not have access to any broadband at all, and that cannot be captured in this data. Also, the data is very uniform across Baltimore City, as I mentioned before, but if we compare Baltimore City as a whole to Maryland, we see a huge disparity. About 61% of people in Baltimore have speeds at or below 25 megabytes per second, which is that threshold of basic internet speed, compared to Maryland, where only 35% of individuals have speeds 25 megabytes per second or lower. So to connect this to the larger issues here, we know that this is so important. like broadband access is tied to quality of life because it means childhood education, quality information, and it means access to potentially working from home. So if we take this data and compare it to racial demographics or median income, we see that we can make a case for more funding in Baltimore for broadband access or allowing people to have faster internet speeds because we know it's so important. So thank you all for listening to me speak about this issue.
Excellent, Ruth. Thank you so much. And you'll get to hear more from Ruth in the breakout rooms too, but ask her questions like you've been asking Brian, and hopefully you can respond to them before we go into the breakout room. But great job. And we're going to turn it over to our last team, Michael and Naomi.
Oh, cool. Hi, everyone. Welcome to our presentation on OpenStreetMaps. My name is Michael Vandi, and I'm an AIT senior at the University of Baltimore, and I'm part of the Summer Data Science Corps here at Priya. I'm going to give my colleague Naomi a chance to introduce herself.
Hi, everyone. I'm Naomi Weiss. I am a data analytics student at the University of Baltimore. I'm planning on graduating this fall. And I am also part of the Data Science Corps this summer.
Okay, so together we're part of the OpenStreetMap team here at Priya. Some of you may be familiar with OpenStreetMap or got introduced to it at the Mapathon we had last night as part of the events for Baltimore Data Week, where we added over 2,000 points in 2 hours. So thank you to everyone who contributed to that. For people who weren't on last night, we are going to give a quick overview of what OpenStreetMap is. So OpenStreetMap is a free and collaborative map that allows the general public to add and edit geodata. The project was started in 2004 and relies primarily on crowdsourced data made available under the Open Database license. This includes data about roads, buildings, addresses, businesses, natural features, and just about anything. The data is acquired from personal knowledge, street-level image data, and government data. Editing points in the map can be done online using the OpenStreetMap editor. So if there's a store in your community that recently changed their name or moved elsewhere, you can head over to openstreetmap.org and update it. So it's kind of like the Wikipedia of maps. As of July 2020, according to OpenStreetMap, the platform has about 6 million registered users, and they receive about 3.5 million map changes per day. And there are a total of 6 billion nodes on the map. A node is a point on the map that has a specific longitude and latitude value. Next slide, please. A lot of companies, platforms, and organizations use OpenStreetMap, including Amazon, Craigslist, Facebook, Foursquare, Uber. Uber actually use OpenStreetMap as their main map interface for locating drivers and setting points. And I did not know this until 2 days ago because the Uber map interface and the generic OpenStreetMap interface are so different. But that really speaks to how customizable OpenStreetMap is. Other companies are Microsoft, Snapchat, Tesla, TripAdvisor, Flickr, Famous, Bookman Go, and many more. Next slide, please. So here's our typical workflow when we do OpenStreetMap projects. So first of all, we get the data. And we get the data from a variety of sources. For example, our project with COVID-19 testing sites, we got data from baltimorecity.gov and the Office of the City Council. And after getting the data, we verify that data to make sure that it's accurate. Going back to our COVID-19 project, there were some mobile testing sites, and we had to verify that those sites were there before adding it to OpenStreetMap. And after verifying the data, we geocode or reverse geocode, as the case may be, Sometimes we only get data that has street addresses, and then we'd have to geocode that to get longitude and latitude values. Sometimes we only get longitude and latitude values, and we'd have to reverse geocode that to get street addresses. After that, we divvy up tasks amongst ourselves. Naomi and I typically take up half the tasks each. And then we head over to openstreetmap.org and add points that weren't on the map, edit points that were already on the map but needed some changes, and remove points that aren't valid. So I'm going to pass the torch to Naomi to talk about our current OpenStreetMap project.
So what we started with is adding testing sites to the map for COVID-19. So there were 23 testing sites in Baltimore City, and they are grouped into 4 categories. There's the medical center testing sites, the community testing tents, pharmacies, and neighborhood mobile testing sites. And as Michael mentioned, we had to be very careful with those because some of them are short term, and we had to make sure to verify the information so that it wasn't out of date or a testing site hadn't changed location. So this is an example of a site testing site that we added. This is the Family Health Center of Baltimore. So the building was actually on the map already, but it didn't have any information, not even the address. So we had to add in the address, the name, the testing times that were available, phone numbers to make appointments, whether it's you can walk in or it's drive-through only. So you can add tags with all that information. Some of the points that we added were already there, like a University of Maryland testing center. Obviously University of Maryland was already on there, but we had to add specifically that there was a COVID testing site there and the specific number you can call to make appointments. And other testing sites weren't on there at all, so we had to add in buildings or points. Can you go to the next slide? Okay, and the next steps we want to take, we want to add more COVID resources to OpenStreetMaps. We want to finish mapping food distribution sites and resources for people without health insurance and all sorts of different COVID resources. And we want to build a tool like a mobile app or a web app to help look up testing sites, something that you could put in your location and the hours that you're looking for, and it would pull up sites that are close to you and directions. And there aren't any apps currently that have all that information integrated with conditional lookups that will allow you to put in multiple variables. And okay, can you go to the next slide? So, excuse me, editing OpenStreetMap is important because it's a huge collaborative community effort. Everybody adds information and it benefits everybody, organizations and individuals. And it's constantly, the great thing about us is constantly being updated. So either we'll update our points or somebody else will update them, and that makes sure that all information is current and accurate, and then all this information can be shared with everybody.
To add to that, working with BNIA for the past month has been a truly amazing experience. I joined BNIA personally to learn about data science and see how we could use geospatial data. And believe me, we have a lot of it to improve urban commuting in Baltimore City. And there's been a number of events during Baltimore Data Week that align with that goal, ranging from the event on Wednesday about slow streets transit to the Mapathon yesterday and the census event that just concluded. There are a ton of ideas that we could take away from this Baltimore Data Week moving forward. We have census data, we have scooter data, we have housing data. We could take all these multi-constituent resources and integrate them together with analysis to recommend, for example, more bus lines in places where there might be a lot more people. And not only based on the population, but based on the population of people who actually use the buses. So I'm really excited for that in the coming months, and this experience has been truly fulfilling. So thank you so much for listening, and any questions?
What an amazing segue into kind of how we're going to proceed. So we want to actually try and literally answer some of the questions that Michael has concluded with. So now that they've got this big foundation underneath them, where do they go from here? And so what we want to do, because I know hopefully everybody was energized after those 3 presentations, is allow you the chance to actually interact. So we are going to go into 3 breakout rooms, and in each breakout room is one of the PIs from the data science. So it's Mike, Sharad, Aryya, Nirmalya. You can see PI next to there. One of us is going to be in those rooms. One of the data science, 1 or 2 of the data science fellows is going to be in your room. And then 1 or 2 of the BINIA folks are going to be in your room. And we're going to try and answer these 2 questions, which Michael kind of, that are in the chat. What kind of issues should we be looking at in Baltimore? The NSF project that we're in is a 2-year opportunity to kind of deploy all kinds of data science students, not just from the University of Baltimore, but from all of our institutions, to try and look at social good problems. And then what are some of the skills that we're going to have to focus on, our collective knowledge